In this video, we are going to conclude the topics for chapter 2. We are now going to look into density. Density is a physical property of matter, which compares the mass of an object to its volume. That means that we can actually see one of the properties of matter. And if we have different types of matter in one vessel, we can see what is their behavior. Density is actually given by a particular mathematical equation that we can see that it is given specifically right here on the slide. To calculate density, you will need the mass of your substance, and you're going to divide it by the volume of the substance. So let's say that, for example, in the laboratory, we have a beaker that has different substances. Here in the image, in the beaker, we have a piece of cork, ice, water, aluminum, and lead. These different substances, as you can see, are distinct. The one that we have in larger amount is the water. And in parentheses, we have the densities of each of the different substances. We can see that the density of water is 1. And it's going to be this clear, colorless liquid that is going to be mostly in the beaker. If we see what is the behavior of ice, which is a different form of water, it's just water in solid form, and we see a piece of cork, we can see that they have a different behavior compared to the piece of aluminum and the piece of lead. While the piece of cork and ice is floating in the beaker, we can see that the aluminum and the lead, it actually sank into the beaker. That's because of the density of each of the substances. The cork and ice is less dense than water, so that's why we see them floating. On the other hand, because aluminum and lead are more dense than water, we can see the values here, we see them sinking in the beaker. The density of substances also are utilized in order to create very interesting drinks. So the picture that you observe right here, this is just has like different colors and layers. And that's because the density of these different liquids are going to be different from one another. And that's why you can create that gradient effect in that particular drink. So here in the table, we have different materials. We have corn syrup, we have water with food coloring, we have vegetable oil, we have baby oil, we have honey. Now, each of these substances has a particular density. Let's say that, for example, I select out of these substances, and I'm going to highlight them with different colors. I'm going to select here specifically the dark caro syrup, that this is its density. I'm going to select the Dawn dishwashing, and this is its density. And then I'm going to select baby oil, and this is its density. I want you to take a moment, and with the concept of density, we are going to rationalize that, taking into account that possibly these 3 substances do not interact with one another. If we place them in a graduated cylinder, which is the image that you see to the right of that table. How would these three substances create a gradient just like we see right here? So based on the substance's densities, if you determine that the dark caro syrup will be in the bottom, that is correct because it's the most dense out of the material, followed by the dishwash soap, and lastly, the baby oil. Because overall, when these gradients are created and we are utilizing density, the most dense goes in the bottom and then is followed on top by the things that are the least dense. From page 86 in the textbook, let's go over problem 2.89. So now that we have conceptually been introduced to density, let's read the following problem. Each of the following diagrams represent a container of water in a cube. Some cubes float while others sink. Let's match the diagrams 1 through 4 with one of the following descriptions and explain your choices. So I want you to take a moment and determine which illustration corresponds to the cube has a greater density than water. Next, determine the illustration that corresponds to the cube has a density that is 0.80 grams per milliliter. Next, select the image that corresponds to the cube has a density that it is 1/2 of the density of water. And lastly, determine what is the illustration that corresponds to the cube has the same density of water. Remember that the density of water is 1.00 grams per milliliter. Since we have an equation in order to determine density, it is important that we know how to calculate density. And in order to do this, we're going to practice by doing problem 2.70 from page 81 in our textbook. The problem reads, what is the density in grams per milliliter of each of the following samples? I am specifically going to be doing letter A. In letter A, it says that an ebony carving has a mass of 275 grams and a volume of 207 centimeters cubed. First, let's establish that the equation that I need is here. Density equals mass over volume for the substance that I'm interested in. And in problem A, I have an ebony carving. I record the information that is given to me. I know that the mass is 275 grams. I see that the volume is 207 centimeters cubed. Now, what is needed is the density but I need it in units of grams per milliliters. Taking that into consideration and looking at the units that I need, grams and grams, check. Milliliters and centimeter cubes do not match. So I should find an equality that is going to transform centimeters cubed to milliliters. So taking that into consideration and looking at some of the information that I have in table 2.7, I can see that milliliters and centimeter cubes is the same thing. It's a one-to-one relationship. So I can already change this and say, well, 207 centimeter cube is the same thing as saying 207 milliliters. Now that I have the properties in the right units, then I can proceed to put it into my equation, which determines that density equals mass over volume. The mass is 275 grams. The volume is 207 milliliters. In units of gram per milliliters, I put these numbers into my calculator. 275 divided by 207. I see a calculator display with many digits. But once I have to determine how many digits did I write down, here I'm doing a division. And since I have 3 significant figures here and 3 significant figures here, I need to round my calculator display to 3 significant figures. So my final answer is 1.33 grams per milliliter. Make sure that you practice by doing problems B and C. Since now we learned how to calculate density, if we're given other parameters within density, we can calculate mass or volume. So let's determine how does the equation will look like if we're looking at the measurements of mass and density, and we are giving the other two parameters within the context of the problem. So the equation for density, I already gave it in the previous slide. Density equals mass divided by volume. Using algebra, I can isolate from this equation the mass term, which determines that mass is going to equal to density times volume. Utilizing algebra, I can also separate the volume term of this equation. And I know that volume equals mass over density. Now that you have all three equations, then we can proceed to look at problem 2.68 on page 81 and perform some of these calculations. The problem reads, calculate the volume of the samples in A and B and the mass of those in C and D. So as an example, I'm going to be doing letters A and letter C. Let's first do 2.68 letter A, where we are calculating volume. When we are calculating volume, I can see that we are going to be given some information. Let's read the problem. What is the volume of a 1.22 grams of a solid with a density of 0.92 grams per milliliter? So I'm going to write down the equation that is needed. Since I'm calculating volume, I'm going to write my volume equation. in the problem, M is 1.22 grams. Density is 0.92 grams per milliliter. When I divide these two measurements, the units of grams cancel. So that means that for this problem, the volume is going to be given in milliliters. When I take these two numbers, 1.22, and I divide it by 0.92, I have many digits in my calculator display. But utilizing the rules for significant figures in measurements, depending on the mathematical operation, how many sig figs do I need in this volume? If you determined that you need two significant figures, you're correct. This measurement has 3. This measurement has 2 significant figures. So our final answer needs to be rounded to 2 significant figures. So the volume of this sample is 1.3 milliliters. Let's now move on to problem C, where it reads, what is the mass in kilograms of 30 milliliters of a liquid with a density of 4.3 grams per milliliter? So I'm trying to determine mass. So I know my equation is mass equals density times volume. But in addition, I should write a note that mass, it has to be in units of kilograms. We have to keep that in mind. When I read the problem, since I know that mass equals density times volume, I'm going to find the density. It tells me that it's 4.3 grams per milliliter. My volume is 30 milliliter. When I look at the units and how they cancel, milliliters cancels with milliliters. So when I take 4.3 and I multiply it by 30, I see an answer of 129. Now, it is important that when I keep on looking at the units, I notice that this is in grams. So I'm not done with the problem yet, because since my unit is in grams and I need kilograms, there's one more step that I need to do. Now I need to take these grams and change them into kilograms. Throughout these videos, you have learned different techniques to convert from metric to metric conversion. And you can choose the one that you prefer to utilize. I give you different tools. Use the one that makes more sense to you. So when it comes to this, you can utilize the number line method. You can utilize dimensional analysis. Let me just conclude this with dimensional analysis, which, if you know the equality between grams and kilograms, it actually establishes that 1 kilogram equals 1,000 grams. So what this means is that if I'm using dimensional analysis to convert from grams to kilograms, I'm going to say 129 grams. I'm going to, in the bottom, say 1,000 grams, on top 1 kilogram. The units of grams cancel. And when I take 129 and I divide it by 1,000, I have a result of 0.129. 9 kilograms. Now, when it comes to the final answer, I need to keep track of my sig figs. So take a moment and determine how many sig figs need to be in the final answer. When we look at our measurements, this has 2 sig figs. This has 1 sig fig. So we need to round this answer to one significant figure, which means that our final answer is 0.1 kilograms. Make sure that you practice with problem B and problem D.